I welcome you all for a video presentation on the subject operating systems. The topic I'll be discussing in this video presentation is exploring the world of operating systems, which would be a comprehensive overview. Hello everyone, I am Bharat M of third semester belonging to Computer Science Department of Artificial Intelligence at the Venkateshwara College of Engineering. Let us look on about the contents of the video. Here, first we will be looking at an introduction to operating systems. Later, we will be discussing various topics like evolution of operating system, types of operating systems, functions of operating systems, types of file systems, special purpose system, security and protection, user interface and interaction. We'll also look at distributed systems and cloud computing. And before we finish this video, let us look at the future trends of operating system and then we would conclude with the video. Now, let us start with the introduction of this. In this presentation, we will delve into the power of operating systems and their impact on modern technology. We will explore the foundations and evolution of operating systems as well as their crucial role in computing. An operating system serves as the crucial intermediary between hardware and software, enabling seamless interactions and resource management. It provides essential services such as memory management, process scheduling, and file system access. This is how operating system is, and this is what we looked up the introduction. Let us get into the main content of the video, topic by topic. Let us start with evolution of operating systems. How operating system evolved from the early stages to what it is today. From the early days of mainframe systems to the era of personal computers and mobile devices, operating systems have evolved to meet the demands of diverse computing environments. Now, in this video, we will explore some of the key milestones and innovations. The evolution of operating system dates back to 1950s with the advent of batch processing systems. Over the years, what happened is a lot of significant milestones such as the development of Unix and the introduction of graphical user interfaces have shaped the landscape of operating systems. Now let us look at different types of operating systems. If there is an operating system, it is sure that there will be many types, more than one. Let us look at all of those. The first one is real-time operating system. This one is designed to handle real-time applications with strict timing constraints. Another thing is real-time operating systems prioritizes tasks based on their urgency and guarantees timely execution. The next type of operating system is the single user operating system. This single user operating system is designed to support a single user at a time. This allows the user to have complete control over the system resources. And next type is multi-user operating system, designed to support multiple users simultaneously, allows the users to share system resources and work on different tasks concurrently. Another type of operating system is the distributed operating system. This distributed operating system consists of multiple interconnected computers that work together as a single system. A lot of computers, they work together in the form of a single system. This is able to be achieved by the distributed operating system. This enables resource sharing and coordination among all the distributed nodes. Next is the embedded operating system, designed to run on a small or specialized devices with limited resources. So what is the specialty of this is an embedded operating system can work only on that particular device for which it is designed. The same operating system cannot work on a different device which it is not made for. This one is optimized for specific tasks and often built into the device hardware. The next one, let us look at the functions of operating systems. What are the tasks performed by the operating systems? First thing is, it is about the process management. The operating system is responsible for managing processes, which are the executing instances of a program. It allocates resources such as CPU, time and memory to processes and ensures their proper execution. It also handles process scheduling, synchronization and inter-process communication. The second function of operating system, let us look at it, is memory management. The operating system manages the computer's memory, ensuring that each process has enough memory to execute and that memory is allocated efficiently. This one handles memory allocation and deallocation, memory protection, and virtual memory management. It also performs tasks such as swapping process in and out of memory and managing memory caches. The third function of operating system today, which we would be seeing, is storage management. The operating system manages the computer's storage devices such as hard drives and solid state drives. It handles tasks such as file system creation, file allocation, and file access. It also manages disk space, ensuring sufficient storage, utilization, and handling tasks such as disk scheduling and disk error handling. The next function let us look at is about device management. The operating system manages the computer's devices such as printers, scanners, and network interfaces. It handles tasks such as device driver management, device initialization, and device communication. It also provides an interface for applications to interact with devices, abstracting the low-level details of device operations. And one last function of operating system which you would see now is about the file system management. The operating system manages the computer's file systems which organize and store files on storage devices. It handles tasks such as file creation, file deletion, and file access permission. It also provides file organization and retrieval mechanisms such as directories and file indexing to facilitate efficient file management and access. Now, we spoke about file systems, and in this slide we'll look about the different types of file system. One is file allocation table 32. This thing is supported by most operating system. It has a limited file size and partition size. Second one, new technology file system. This supports large file sizes and partition sizes, and it has a lot of built-in security features. Third one is hierarchical file system plus. This specific file system is used by Apple's Mac OS, supports journaling and file compression. Fourth one is fourth extended file system. This extended file system is used by Linux, supports large file sizes and partition sizes, and it's also used for journaling. The next one is Apple file system. As the name suggests, this is used by Apple's macOS and iOS. This supports encryption and snapshotting. The last one type of file system which we'll look is the extended file allocation table. This file system supports large file sizes and partition sizes compatible with Windows and Mac OS. Special purpose systems, real-time operating systems are designed to respond to events and complete tasks within strict time constraint. They are commonly used in industries such as aerospace, automotive, and industrial automation where timing and reliability are very critical. Embedded systems are those special kind of operating system that are designed to run on specialized hardware and control specific functions of a device. They are commonly found in devices such as smartphones, smart appliances, and automotive systems, where the operating system is integrated into the device itself. Next, let us see about the mobile operating systems. Mobile operating systems are designed for smartphones and other mobile devices. They provide a user interface, manage hardware resources, and support mobile applications. Examples of mobile operating systems include Android and iOS. Now let us look about the security and protection of operating system. Security and protection mechanisms are vital components of modern operating systems to safeguard against unauthorized access, data breaches, and malware threats. Techniques such as access control, encryption, and secure boot ensure the integrity and confidentiality of system resources. Operating systems implement various security measures to protect against unauthorized access and malicious activities. Operating systems also employ protection mechanisms to safeguard data and resources from unauthorized modification or destruction. Now, let us look at the next slide, which is user interface and interaction. Here we will look into two divisions of the slide. One is usability and another is accessibility. Under usability, let us see, designing effective user interfaces for operating system requires a focus on usability. This means creating interfaces that are easy to use, intuitive, and efficient. Some key considerations for usability include clear and concise labeling of buttons and control, consistent layout and design across different screens and interfaces, efficient use of screen real estate and minimization of clutter. Accessibility. In addition to usability, designing effective user interfaces for operating system also requires a focus on accessibility. This means creating interfaces that are accessible to users with disabilities, such as those with visual or motor impairments. Some key considerations for accessibility include clear and legible text and labels for all users, consistent use of color and contrast to ensure readability for users with visual impairments, providing alternative text and descriptions for images and other non-text content. Let us look at the next slide. It is about the distributed systems and cloud computing. The advent of distributed systems and cloud computing has transformed the landscape of operating systems, enabling scalable, on-demand resources and seamless collaboration. Networking and distributed operating systems enable seamless communication and resource sharing across interconnected devices. Concepts such as client-server architecture, peer-to-peer networks, and distributed file system form the foundation of modern networked environments. Let's go on to the 12th slide. Before finishing, let us look on what are the future trends of operating system. Here, the main thing which we discuss here is about the future of operating system is evolving with advancements in virtualization, containerization, and cloud computing. Concepts such as container orchestration and serverless computing are reshaping the landscape of operating system architectures and deployment models. From containerization and virtualization to edge computing and IoT integration, operating systems are at the forefront of technological innovation. We are still exploring the latest trends shaping the future of operating systems. As technology advances, operating systems face challenges such as security threats, compatibility issues, and scalability demands. We will discuss the potential solutions and the future trajectory of operating systems. And let us conclude the video presentation over here. In conclusion, operating systems form the backbone of modern computing, enabling seamless interaction, resource management, and security. Their evolution and adaptation to emerging technologies continue to shape the digital landscape. As technology continues to evolve, operating systems will adapt to meet the demands of diverse applications and computing environments. So this was here about the video presentation, which was a comprehensive overview on the topic operating systems. This is the subject we looked into this video. We looked at the different types of operating systems, different types of file systems, storage management, securities and protections, and how there is a future for the operating systems. We even discussed about the trends in operating systems, and we conclude here for this video. Thank you everyone for being a part of this session. Thank you very much. See you soon.